Greetings, chemistry students. This is Mr. Harper with a brief tutorial on balancing equations. If you were not here last Friday in class, this is mandatory viewing. We will have a quiz on Monday when we return, so you want to make sure that you have watched this podcast, that you have taken notes, and that you understand what it is you're supposed to be doing. Additionally, there is a worksheet that you will find on my website that you guys need to download and complete all 50 of the problems on. So, here we go. That'll be due Monday, of course, when we return as well. So, let's talk here briefly, guys, about how to balance chemical equations, okay? Well, first of all, let's talk about what a chemical equation is, and I'm going to show you one so that you know what one is, okay? A chemical equation is a written representation of a chemical reaction, okay? And what it shows are the ingredients, the things we start with, and things that are formed in the chemical reaction, okay? So basically, this is what it tells you. What things react, okay? What forms during the reaction, and then also what ratio they react and form in, okay? Here's an example right here. This equation shows here we have a molecule of hydrogen reacting with a molecule of oxygen to give a molecule of water over here on the product side, okay? So here's a pictorial representation. These over here, these things we start with on the left side of the arrow are called the reactants. This is a graphical representation of my hydrogen, my H2 molecule, because we have two. What this says, you just remember a reminder, guys, in the formula, this subscript 2 says we have two hydrogen atoms joined together into a molecule. This guy right here, O2, oxygen molecule, we have two oxygen atoms joined together to make one molecule of O2, okay? These collectively are the reactants, okay? This arrow here kind of means reacts to form or yields, and then the products over here. In this case, the products is a molecule of water, H2O. Here's a graphical representation where we have my two hydrogen atoms joined to one atom of oxygen to make my water molecule. There we go. If I wanted to read this equation as a sentence, okay, it would go like this. It would say that one molecule of hydrogen reacts with one molecule of oxygen to yield or to give or to form one molecule of water. And there we go. That's what this chemical equation tells us, okay? But if you look at it, there is something that is quite obviously wrong with this chemical equation. If you look, and let me give you guys a second here to think about what this is, okay? If you want to, pause it in case you can think about it, but if you don't want to, I'll just tell you, okay? Over here, if you guys take a look at it, here in my hydrogen molecule, I have two hydrogen atoms. On the product side of the equation, over here, in my water molecule, I also have two hydrogen atoms. However, in the reactants here, I have two oxygen atoms, okay, in my O2 molecule. In the product side, in my water molecule, I have only one oxygen atom. We say that this chemical equation is unbalanced. And what that means is that there's not the same number of atoms of each type on both sides of the equation. According to the law of conservation of matter, we have to have the same number of atoms of each type in the reactants before the reaction happens and on the product side. Or in other words, we've got two oxygen atoms over here in the reactant side. We have to have two oxygen atoms over here in the product side. Right now the equation is unbalanced. We have to balance it to make it valid. Okay? Now here's how we're going to do that. Okay? You can, we have to delete that. You can see, guys, that if I wanted to change this equation somehow to make it so that I've got two oxygen atoms here on the product side, well, what could I do? Okay? Well, what I could do is imagine, say that I had, instead of having one water molecule produced, say that I had two water molecules produced. Say that I had two of these guys here instead. I'll just tack on another water molecule over here in the product side. If I had two water molecules, each water molecule has one hydrogen atom within it, then I'd have two oxygen atoms here on the product side, and then that would be okay. But now if we look at it, if I have two molecules of water, okay, let's think on the product side then how many hydrogen atoms I would have. If I have two water molecules, each water molecule has two hydrogen atoms. That means on the product side of the equation, I would have a total of 4 hydrogen atoms. In the reactants, I only have 2. So now I have to change this side of the equation too to make the whole thing balance. I'm going to have to put a 2 here in front. If I had 2 of these hydrogen atoms here to start with, or hydrogen molecules I should say to start with, then I'd have a total of 4 hydrogen atoms on this side, and I'd have 4 hydrogen atoms on this side. Over on this side, I would have a total of 2 oxygen atoms On this side, I have 2 oxygen atoms. And now the whole equation is balanced. Okay? Let me go on into the next slide here. This picture here is showing just a graphical representation of the reaction, so you guys can see that now if I put these numbers 2 here in front of, I have 2 molecules of hydrogen and 1 molecule of oxygen. These guys will react to give 2 molecules of water. And if I compare, I can see that I've got my 2 oxygens on this side, I have 2 oxygens over here, I have a total of 4 hydrogen over here, and I have a total of 4 hydrogen over here. Now that equation is balanced, and it obeys the law of conservation of matter. That's what we're going to practice doing here today, guys, is how to balance a chemical equation and make it so that there are the same number of atoms of each type on both sides of the equation. Okay, so here's some rules. To balance an equation, here's the guidelines. You cannot change the subscripts. Now, what do I mean by subscripts, guys? What I mean by subscripts is this right here. Okay, if I look at my molecule H2O, that guy right there is the subscript. This tells me that there are 2 hydrogens and 1 oxygen in a molecule of water. I cannot just change this and make that a 2, for example, because now this is a totally different molecule. This is hydrogen peroxide, not water. Okay, so it's a different substance. You cannot change the subscripts because that changes the identity of the chemical. Okay? Another thing you cannot do, you cannot add or subtract reactants or products. So, for example, in my original equation where we had H2O plus O2 yields H2O, okay? I told you originally, guys, that the problem with this equation was that we only had 1 oxygen over here, we had 2 over here. I cannot just say plus oxygen over here to make that balance out. That does not work because now I've changed my equation. I've changed the entire meaning. Now what this tells me is that instead of getting water as a product, I get water plus an oxygen radical, which is not what's going on. So we cannot add a new product or a new reactant, and we can't subtract something that's already here because that changes the meaning of the equation. Okay? The only thing that you can do is you can only change the coefficients. Okay? Coefficients, what that is, okay? If you think to algebra, okay, say I look at this number 2x, the coefficient is this number right here. It's the number out in front. It's the multiplier. This tells me how many of x I have got, okay? In that original equation, hydrogen plus oxygen yields H2O, okay? My coefficients are the numbers out in front. Notice when I balance that equation, what I said is, okay, we can make it work if we have 2 of these and we have 2 of these. Here are my coefficients, guys. I put a new coefficient out here in front, a new multiplier. I made these both 2, and this one, since there's no number out in front, it's understood that if there's nothing out in front of the oxygen here, that really is just 1, okay? But there we go. That's what I can do is I can change the multiplier, the coefficient out front, okay? Let's look at another example. Here's another reaction right here. And my reactants on the left side of the arrow, the chemicals that I start with, we have a nitrogen molecule and a hydrogen molecule. On the product side here, we have an ammonia, NH3. Okay, this is what we produce during the course of the reaction. So nitrogen and hydrogen react to produce ammonia. Now notice, guys, again, what's wrong with this equation is that we do not have the right or the same number of atoms of each type on both sides of the equation. On the reactant side, I have 2 atoms of nitrogen. On the product side, I only have got 1. On the reactant side of the equation, I have 2 atoms of hydrogen. On the product side, I've got 3, so there's different numbers. So to balance the equation, we're going to change the coefficients. In each molecule of nitrogen, I'm going to start with nitrogen here, guys. In each molecule of ammonia, you can see that I've got 1 nitrogen atom. Here's my graphical representation, okay? On this side of the equation, I've got 2 atoms of nitrogen. So to make it on the product side so that I have 2 atoms of nitrogen, I'm going to put a coefficient of 2 out here in front. That multiplies this whole thing by 2. That says I get 2 ammonia molecules out. In each ammonia molecule, I've got 1 nitrogen. So now a total over here on the right side of the equation, guys, I've got 2 nitrogen atoms. Over here, I've got 2 nitrogen atoms. Now that works out. And now you can see that over here on the product side, guys, if I have 2 molecules of ammonia, each molecule of ammonia has 3 atoms of hydrogen. I'll have a total of 6 atoms of hydrogen on the product side. I have to change it now on the reactant side to where I also have got 6 atoms of hydrogen. You can see that in each molecule of H2, I've got 2 atoms of hydrogen. To make it so that I've got 6 on this side, I have to put a coefficient of 3 out here in front of the hydrogen. Now if I multiply through, I have 6 atoms of hydrogen on this side, I have 6 atoms of hydrogen on this side. I have a total of 2 atoms of nitrogen on this side. I have 2 nitrogen atoms on this side. Now that turkey here is balanced and everything is beautiful. Okay? If you take a look here at my final graphical representation, okay, here we go. Here's the balanced equation. Okay, so we got 1 molecule of nitrogen reacts with 3 molecules of hydrogen to give me 2 molecules of ammonia. And if I total up on both sides of the equation, the number of atoms of nitrogen and the number of atoms of hydrogen are exactly the same on both sides. And there we go. Okay? That is briefly how to balance equations. Now, one more set of guidelines I'm going to give you guys is people ask me every year, okay, what order do you balance things in, Mr. Harper? Where do you start? Because if you see that an equation isn't balanced, what should you start with? Here's the order, okay? And I'm going to give you a mnemonic device to remember this, okay? The first thing you want to look at are M stands for metals. You want to look for metals first and balance metals first. This is a good place to start. After that, balance ions if there are any, such as polyatomic ions. You may remember, guys, the polyatomic ions are those ones that consist of more than one atom, and those whole things behave as a unit. So things like nitrate, NO3- is a polyatomic ion. Sulfate, SO42- is a polyatomic ion. Hydroxide is a polyatomic ion. These are just some examples, okay? After ions, you want to balance nonmetals besides hydrogen and oxygen. Examples would be things like nitrogen, phosphorus, sulfur. These are all nonmetals. Balance those next. After that, balance oxygen. After that, balance the hydrogen, okay? The mnemonic device is MINO, okay? And this tells you the order. So M for metals, I for ions, N for nonmetals, O for oxygen, H for hydrogen. If you remember MINO, that's the order you guys want to balance things in. Now, the last thing I'm going to tell you guys is, you want to write this down. At the end, after you're done balancing the equation, double check everything. Because when you change one coefficient, that can change the entire balance, the entire thing. And so you want to make sure at the end, when you think you're done, that things actually do even out. So now what I want to do is we're going to do some examples. And there's 3 example problems here I'm putting on the screen. If you're feeling pretty confident, what I'd like you guys to do is to stop the recording or pause the recording and try to balance these on your own. Okay? And then bring it back up, play it again here in a second, and I'll run through the answers with you. Okay? So pause right now and try these yourself. Okay, and we're back. Let's look at the first equation first, okay? We can see here that we have sodium and oxygen reacting to give sodium oxide, okay? Now, I'm going to remember my mnemonic device, MINO, and we're going to go here in order. The first thing I want to start with here is my metals. Notice here, guys, we do have a metal. We have the metal here being sodium on both sides of the equation. Let's check and see if that's balanced. If I look on my reactant side, I have only 1 sodium atom. On this side here, within the sodium oxide unit, I have 2 sodiums. So right now the sodium is not balanced. To make that work out, I'm going to have to put maybe a 2 here in front of my sodium, okay? Now I've got the same number of sodium atoms on both sides of the equation, okay? That's balanced out. Now let's check oxygen. On this side of the equation, I have 2 oxygen atoms. On this side of the equation, I only have 1. To make it so that I've got 2 oxygen atoms on this side of the equation, I'm going to have to slap a 2 here in front of that whole thing. Remember that I cannot do that. I cannot change the subscript because that changes the compounds. That we're, no. We want to continue recording. Okay, can't change that. Can only change the coefficient out here in front. Okay, now let's just double check here at the end because I balanced my sodium first. Now I balance the oxygen out. Let's just double check. On this side of the equation, on the product side, I've got 2 oxygens. I've got 2 oxygens over here. Oxygen now is balanced. Over here, I've got, if I total it up, I have 2 times 2 is 4 sodiums. Over here now I only have 2. Notice, guys, that when I put this 2 out in front of here, it did not just change the number of oxygens, it also changed the number of sodiums. Now to balance the sodiums out, since I have 4 on this side, I have to change this coefficient over here now to 4. Now I have 4 sodiums on this side, I have 4 sodiums on this side. Everything is good, everything is balanced, life is beautiful. Okay, let's look at the next equation. I'm going to go through my list. Do I have any metals? No, I have no metals. I have no ions. Let's look at nonmetals next. I do have some nonmetals, okay? Besides oxygen and hydrogen, I have carbon, okay? If I look on this side of the equation, I have 1 carbon. On this side, I have 1 carbon. Carbons are balanced. Those are good. The next thing I want to do here is now look at my oxygens, okay? And see if that's balanced. If I look at the reactant side of the equation, I have 2 oxygen atoms. On this side of the equation, I have 2 oxygen atoms here, and I have 1 oxygen atom here in the water for a total of 3. Okay? The oxygen is not balanced on both sides of the equation. Okay? I have to change coefficients in order to balance it. If I look at this side of the equation, guys, oxygen is only going to come in multiples of 2, because what I'm working with here is O2, the diatomic oxygen molecule. Each molecule of oxygen contains 2 oxygens, which means that the total number of oxygens over here on the product side of the equation has to be a multiple of 2. Right now I have a total of 3, but what if I put a 2 out here in front of this guy? If I put a 2 there, then I have 2, each water molecule's got 1 oxygen. If I have 2 water molecules, I have 2 oxygens, plus 2 oxygens here is 4. If I look over here now, each oxygen molecule has 2 oxygens. I can slap a 2 out here in front. Now I've got 4 oxygen atoms over on this side. The oxygens now are balanced. Oxygens are balanced. Carbons are balanced. Now let's check hydrogen. On this side of the equation, I have 4 hydrogen atoms. On this side of the equation, I have 4 hydrogen atoms. Hydrogen is balanced. Oxygen is balanced. Carbon is balanced. We're all good. Okay? This baby is done. Let's look here at the last one. This guy right here looks super duper complicated, but in all reality, it is not. It's much simpler than at first it appears, and I'm going to show you guys why. Okay? Let's kind of go through the steps. The first thing we want to look for is metals. Okay? Metals go first. I have 2 metals in this equation. I have sodium, and I have lead. Both these guys are metals. We want to balance those turkeys first. Okay? If I look here at the reactant side of the equation, okay, sodium sulfate right here contains 2 atoms of sodium. Over here on the product side, sodium nitrate contains only 1 atom of sodium. In order to balance my sodium atoms out, I have to slap a 2 in front of the sodium nitrate there. Now I have 2 sodium atoms. I have 2 sodium atoms over here. Life is beautiful, okay? If I look at my lead, okay, I have 1 lead over here. I have 1 lead over here. Lead is balanced. Now that's good. The next thing I want to do is the I. I'm going to check polyatomic ions. If you look here at this example, guys, we see several polyatomic ions. And this guy right here, sodium sulfate, contains this ion, SO4 2-. On this side, lead sulfate also contains the sulfate ion, SO4 2-. Here in this compound, guys, nitrate is likewise a polyatomic ion, NO3-. On this side, nitrate is still intact. We have NO3-. Now, the reason I tell you guys to balance polyatomic ions after metals is because these whole things behave just like a normal atom. These stick together. They remain as a unit. And so I can balance the whole sulfate ion together. If I look on this side of the equation, within this unit of sodium sulfate, I've only got 1 sulfate ion. On this side, I've also only got 1 sulfate ion, and so that balances out. On the reactant side of the equation, guys, I have 2 nitrate ions within the unit of lead nitrate. On the product side, I have 2 nitrate ions because I have 2 units of sodium nitrate. These guys balance because I got 2 of those, and I got 2 of those here. I've got 1 of these here, I got 1 of these here, so they balance. Now the whole equation is balanced. Now, you might ask me, well, Mr. Harper, can I treat this as the sulfur and the oxygen separately and the nitrogen and the oxygen separately? And yes, you could do that, but it's easier to balance the whole polyatomic ions together. Alrighty, guys, that is the end of the notes, the end of the podcast. With that, you should be a little bit more confident in how to balance equations. And with this, you guys need to go forth and do all those homework problems that are on that worksheet that is hosted on my website. If you have any questions, bring them with you on Monday, but we're going to have a quiz first thing. I hope you guys are enjoying your break. Have a good rest of it, and I'll see you on Monday. Goodbye.